Hello folks and welcome back to the Chem School. Today again we are going to start with the aromatic compound nomenclature. If you remember in the last class we spoke about halogen and nitro substituted aromatic compounds and carboxylic acid and its derivatives. The topic for today we are going to start with is phenols and thiophenols. So now let's start with it. If you remember I said if you have a benzene with OH, that is called as phenol. And if I remove the oxygen and replace it with sulfur, right? So I repeat, if I remove oxygen and replace it with sulfur, then the structure that you are going to get is called as thiophenol. So this one is thiophenol. The next one, if you have a benzene with OH and CH3 together, if you remember, benzene with CH3 was toluene and benzene with OH is phenol, but together they are called as cresols. I repeat, together they are called as cresol. Now, you can see that they are adjacent to each other and the position is 1, 2. And we know that if you have 1, 2 substituted compound, they are said to be ortho, right? So this is called as orthocresol, right? Let's have one more example. So the next one, if I have this 1, 2 and 3. So here you have 1, 3 substituted cresol, and we know that if it is 1 and 3 substituted, we call it as meta. So this structure is going to be meta-cresol. I hope you are clear with this. Have a look at the next one. In this case now, if you see, aromatic ring is with OH and with halogens. We know that halogens are substituent. So in this case, the priority will go to OH. So numbering will start from OH onwards. So let's do the numbering first. So this is going to be 1, 2, 3 and 4, right? So you have chloro on 4th position and you have bromo on 3rd position. So as per the alphabetical order, you will write down bromo first. So let's write down. So it is going to be 3 bromo, then 4 chloro, and ultimately if you see the ring, it is going to be phenol. So phenol, benzene with OH, right? So that was your first series. Let's have a look at the next one. If you remember in the last class, I said you that if you have OH and COH, first you need to decide which one is going to be your priority. Obviously, carboxylic acid is a much bigger priority group. So the parent ring is going to be benzoic acid. In the last class, we spoke about it. So definitely in this case, OH is going to be your substituent. So let's do the numbering from the priority group. So 1, 2, 3 and 4. So on 4th group, if OH is your substituent, then it is called as hydroxy, right? So it is going to be 4-hydroxy benzoic acid. And if it is on 4th position, you can also call it as para. So you can also say that this is para-hydroxy benzoic acid. The next one. Now you have benzene with CN, which is benzonitrile, and benzene with OH, which is phenol. Now which one is going to be your priority? Obviously carboxylic acid derivatives. We know that benzonitrile is a carboxylic acid derivative. So numbering will start from CN onwards. So this is going to be 1, 2, 3 and 4. So again you can say this para or 4, anything is fine. So the name will be 4-hydroxy benzonitrile. I hope you recognize this ring. If you have 2 benzene together, it is called as naphthalene, and naphthalene with OH is called as naphthol. I repeat, naphthalene with OH is called as naphthol. Now in this case, if you see, the first position is also called as alpha position. I repeat, the first position is also called as alpha position. This is your beta position, alpha, beta, gamma, delta and so on. So as of now, if you see, you can say that this is 1 naphthol, or you can also call this one as alpha. So you can say that this is alpha naphthol. Both the names are correct, whichever you remember first. Have a look at the next one. Numbering, again phenol is going to be a priority because NO2 is your substituent. So the numbering will be from OH. So 1, 2, 3 and 4. So the name will be on 2 and 4 you have 2 nitro. So dinitro, 2, 4 dinitro phenol. This is also called as DNP, I repeat, 2,4-dinitrophenol is also called as DNP. So if anyone says, okay, give me DNP, so you should remember that they are talking about dinitrophenol. Have a look at the next one. It is in the similar way. So it is 1, 2, 3, 4, 5 and 6. So as per the numbering, you have trinitro on 2, 4 and 6. So 2, 4, 6 trinitrophenol. Now this is a very dangerous compound again, and this is again a kind of explosive, and this is picric acid. This is very important name, so you should memorize this. So if you have trinitrophenol, 2,4,6 trinitrophenol, that is also called as picric acid. This was some of the phenols name. I will give you some more structure to memorize. So let's start with that one. Now folks, these are some important class of phenols again, and now we are going to talk about benzene with 2 OH group, that is called as dihydroxyphenol. If you want to write down the numbering wise nomenclature, that is going to be very simple. That is, if I say that this is going to be 1 and this is going to be 2, so the name is going to be 1,2 dihydroxy benzene, which is very simple, right? But it has a different name, right? So let's talk about those names. So 1,2 dihydroxybenzene is called as catechol. Sounds funny, isn't it? But still, you have to memorize this. So 1,2 dihydroxybenzene is called as catechol. Someone also call, like few people also call it as catechol. So you can call whatever you wish like. Have a look at the next one. If I talk about this structure, this is 1, 2 and 3. So on 1 and 3, you have the substituent. So it is called as 1,3-dihydroxy benzene, right? Similarly, if you talk about the other one, the last one, so it is 1, 2, 3, 4. So they are called as 1,4-dihydroxy benzene. These names are very simple, but the other name for both of this are as follows. So 1,3-dihydroxybenzene is also called as resorcinol. I repeat, it is also called as resorcinol. So I hope this is a fascinating name for you. Have a look at the next one. This one has two names. So 1,4-dihydroxybenzene, you can either call this as hydroquinone or you can call this one as quinol, right? So I repeat, if it is 1,2-dihydroxybenzene, you can call it as catechol. 1,3-dihydroxybenzene, it is called as resorcinol, which is used as an antiseptic. If you have 1,4-dihydroxybenzene, it is called as hydroquinone, or it is also called as quinol. So I hope dihydroxyphenols are very clear for all of you. Have a look at the next one, trihydroxyphenol. So if you have benzene with 3 OH, they are called as trihydroxyphenols. So in trihydroxyphenol, have a look at the first one. So if I give this as numbering 1, so this is going to be 2 and this is going to be 3. So numbering wise, it is called as 1, 2, 3 trihydroxyphenol. Now this is very simple, isn't it? Right? But the other name for this is pyrogalol. I repeat, the other name for this is pyrogalol. This one is also used for water purification. So this is a very important molecule. So I repeat, 1, 2, 3 trihydroxyphenol is called as pyrogalol. The next one, 1, 2, 3, 4, 5 and 6. So you have substituent on 1, 3 and 5. So 1, 3, 5 trihydroxyphenol. Now this is called as fluoroglucinol. So the name is PHLOROGLUCINOL. Fluoroglucinol. It is not F. So you can understand that one. That's very simple. So I repeat, in phenol, you also need to memorize some names for dihydroxy and trihydroxyphenols. There are many other names, but these are the most important ones. So I felt that I should give at least this one for you to memorize. So I hope this is very clear to all of you, the phenol section. So now let's talk about the other important functional groups, that is aldehyde and ketones. Now if you have a benzene with CHO, that is C double bond OH, that is an aldehyde, right? So benzene with CHO is called as benzaldehyde. So let's have a name of its substituents. So if I attach OH to benzene, right, so that becomes phenol. But which one is going to be your priority in this case? So obviously aldehyde, the carbonyl group is always going to be more preferred than this type of groups, right? So let's say, so the carbonyl is your priority, so that becomes 1, 2, 3 and 4. If OH is a substituent, you will call it as hydroxy. So the name becomes 4-hydroxy, and benzene with CHO is benzaldehyde. You can also call this one as para-hydroxy benzaldehyde. I hope you can frame this name very easily now, right? So have a look at the next one. So in this case, obviously nitro is a substituent. So you can see that this is 1, 2 and 3, right? So you can say it is meta-nitro benzaldehyde, or you can say it is 3-nitro benzaldehyde. Have a look at the next one. So if I say this is 1, 2, 3 and 4, so you can say it is 4-methyl benzaldehyde, or this structure has one more name, that is tolualdehyde, because benzene with CH3 is toluene, right, and benzene with CHO is benzaldehyde. So you can club those names together and the name becomes, now because they are para to each other, so definitely you have to say para, right, and then you can say it is tolu and then just write aldehyde. So it is understood that toluene ring is having aldehyde at the para position, so you can break it this way. Fine. Have a look at the next one. Now this is a very important molecule. So if I say this is 1 and this is 2, so you can say it is 2-hydroxy, or you can say orthohydroxy benzaldehyde. And this is also called as salicylaldehyde. I repeat, this is also called as salicylaldehyde. Now why I said this is a very important molecule, because if you oxidize this CHO, it becomes COOH, that is carboxylic acid, and that becomes salicylic acid. And salicylic acid is the starting material for the preparation of a molecule called as aspirin. And aspirin is generally consumed when you have fever, that is, if you have, it is an antipyretic, so it is going to act against the fever. So this is a very, very important starting material or raw material for preparation of salicylic acid, and therefore it is an important molecule. Fine. So let's have a look at some of the ketones. So I have already spoken about this 2 name and have taken one more extra. Why? Because we are talking about ketone and these names are important, so I thought we'll repeat it once again. So have a look at the first one. Now if you have benzene with double bond O, C double bond O, that is called as benzo, and if you have CH3 with C double bond O, it is called as aceto, right? So we will club this name together and this is called as aceto and phenyl. So phenone for ketone. So this becomes acetophenone, right? Here you have 2 benzene attached to C double bond O. So this is your benzo and this is your phenyl. So benzophenone. Like here we said acetophenone. Similarly here you will say it is benzophenone. Now what is going to be the name for this one? So have a look at the longest carbon chain. So this is 1, 2 and 3. So if you have 3 carbon, you will say it is propyl. So it is going to be propio. Fine. And if you have this benzene, so for this benzene we were saying phenol. So just add that extra. So it is propiophenone. So propio for 3 carbon, and for the phenyl ring you will say phen, and for C double bond O you will say it is one. So propiophenone. So I hope that the nomenclature for aldehyde and ketone is very clear to all of you. So let's talk about the next class of aromatic compound, and that is amines. So we are going to talk about aromatic amines as well as some ammonium salts. So let's talk about it. Have a look at the first one. If you remember, in the first class of aromatic compound nomenclature, I spoke about this. So benzene with NH2 is called as aniline. I repeat, benzene with NH2 is called as aniline. So that is going to be your main name, right? And the other are going to be your substituents. So 1, 2, 3, 4, 5 and 6. So let's talk about the substituent position. So you have first substitution on second carbon, then fourth carbon, and then on sixth carbon. So the name will be 2, 4, 6 tri, then this are Br, so bromo, and the main name is going to be aniline. Parent name is going to be aniline. So this is 2,4,6 tribromo aniline. Now this is again a very important compound. Have a look at the next one. So if you have this amine with 2 phenyl on the either sides, then you will say it is diphenyl amine. I repeat, it is called as diphenyl amine. Right? So this was very simple. The next one. Now this is a bit difficult. If you have seen the nomenclature of amines, I have taken a separate video on that. I will attach the link. So do watch that out if you find this one as difficult, right? So that will make your work much easier. So have a look at this one. So on nitrogen you have one methyl attached, and on nitrogen you have this group attached. So this is kind of secondary amines. So if you have nitrogen with 2 carbon substituent, then you say it is a secondary amine, right? So how do we write down the name of the secondary amine? So first write down the name of the substituent. So N has this CH3, so N-methyl. So the name becomes N-methyl, right? And then you will have this particular thing, that is benzene with NH, that is your aniline. So N-methyl aniline. I'm making this name very easy to you, right? So first let's understand what I'm talking about. So first what you will do is N has this methyl and N has this phenyl. So you will write down N-methyl, and then benzene with NH is called as NH2 is called as aniline. So this becomes N-methyl aniline, that is substituted aniline. But if you have something more here, have a look. So this is 1, 2, 3 and 4. So on second carbon you have 1 nitro, and on fourth carbon you have 1 nitro. Now we know that nitro are substituent, and substituent has to be written as prefix. So just add those names as your prefix. So your name becomes 2,4-dinitro. As simple as that. So first worry about the root name. The root name is going to be N-methyl aniline, and then talk about your substituent, which is nothing but 2,4-dinitro group, right? So this is how you will write down the nomenclature. This is very, very simple. Similarly, have a look at the next one. Nitrogen has 3 substituents, so that is going to be tertiary amine, right? Have a look at the alphabetical order. So nitrogen has ethyl, nitrogen has methyl, and nitrogen has phenyl. So phenyl with this is, see, nitrogen ka 2H has been replaced by alkyl group. So again it is an aniline substituent, fine. So aniline is going to be your main parent. So N with this, this is your aniline. The rest of them are going to be your substituent. So write them down in alphabetical order. So N has ethyl and N has methyl. So write down N ethyl, N methyl, and the root parent name is your aniline. I hope this is very, very clear to all of you. Now we know that nitrogen valency is 3, but nitrogen also has a lone pair. If that lone pair is forming some type of salts, then you will get something called as ammonium salt, which is over here, right? So benzene with NH2 is called as aniline, but if I had HCl to it, it will form a salt, right? So this is kind of your salt. So it is aniline salt. So aniline salt are called as, now this particular ion is called as anilium ion, right? So this is your anilium ion and this is your chloride. So you will say this is anilinium, right? So this is called as anilinium chloride, right? So whenever you see benzene with NH3, just say it is anilinium, right? And talk about the anion that is attached, that is anilinium chloride. I hope this is very clear to all of you. Similarly, have a look at the next one. Now in this case you do not have an NH3, but if you have a substituted nitrogen, then also it is fine. So in this case nitrogen has 2-methyl, so you will write down the name like your tertiary one, right? So the name for this will be N. Both the substituent are same, so N comma N, dimethyl. Then this is an anilinium salt, so write down that. So anilinium. And what is your anion? It is bromide. So these are salts. So if you have Br minus say bromide, Cl minus say chloride, SO4 2 minus say sulfate, and so on. Fine. So this is how you will write down the name for your aromatic amines and the ammonium salt. I hope this is very clear to all of you. So with this we have completed with aromatic compound having the benzene nucleus. There are few important hetero-amines for which I am giving you the nomenclature. With that we will complete the aromatic compound nomenclature, and in total we will complete the entire IUPAC nomenclature. So let's talk about hetero-aromatic compounds. So here I have taken some very important hetero-aromatic compounds, and I have also assigned the numbering for them. Fine. So we will also look at the numbering plus their naming. Fine. And I assume that you will all by heart it. Why? Because it is very important. And once you know this, you can see, if you know the IUPAC nomenclature and if you know the names of most of the compound, then if you refer any book, you can understand organic chemistry very well. So these are fundamental or basis of organic chemistry. Therefore, I am insisting that try to memorize this name as much as possible and as early as possible. So have a look. Now, if you have this hetero-aromatic compounds, rule number 1, the numbering will start from the heteroatom. That is, if you have a ring of carbon and if you have any other element apart from carbon, so that particular atom is called as an heteroatom. So in a carbon ring, if you have nitrogen, oxygen, sulfur or any other atoms, so you will start the numbering from that, right? So have a look at the first example. Now if it was C6H6, it would have been benzene, but if I remove one carbon and replace nitrogen in that place, then it will become pyridine or pyridine. This is very important molecule again. So this is pyridine. Okay? Now look, nitrogen I have given the numbering as 1, and then you can go on any side and give the numbering. So it is 2, 3, 4, 5 and 6. So 6 carbon ring with 1 nitrogen is called as pyridine or pyridine, right? Have a look at the next one. If you have again 6 membered ring, but in this case you have 2 nitrogen, and the position of the nitrogen is also very important. So have a look. So if I name this as nitrogen number 1 or first atom, so 1, 2 and 3. So I have nitrogen on first and third position. So this is called as pyrimidine. The names are very close to each other, so try to avoid confusion. So I have only 1 nitrogen, pyridine. If I have 1 and 3 nitrogen in a 6-membered ring, then it is called as pyrimidine or pyrimidine. Now you might have heard this one. Now these are base for your DNA and RNA, right? So these are bases, right? So pyrimidine, base. Next one. If I have 1 and 4 position with nitrogen, then it is called as pyrazine. So only 1 nitrogen, pyridine. 1 and 3 position with nitrogen in 6-membered ring, pyrimidine. 1 and 4 nitrogen in 6-membered ring is pyrazine. Next, if I have a 5-membered ring with only 1 nitrogen, it is called as pyrrole. The numbering will start with nitrogen, of course. Fine. So I repeat, if you have now 5-membered ring with 1 nitrogen, then it is called as pyrrole. Now you might be thinking how this compound is aromatic. Either ways, I am going to start with aromatic, like what are aromatic, how do you decide that this is an aromatic compound in the next class itself. So I will explain this fact to you. Fine. But as of now, you can just remember that either you should have lone pair or pi bond alternate to each other, like pair of electrons should be alternate to each other, as simple as that. So even if you have a negative charge, that will do. So in this case, what you have, lone pair. So lone pair, single bond, double bond, single bond, double bond, single bond, lone pair. So you can see that 2 electrons are alternate to each other. The pi electrons and this lone pair electrons are alternate to each other. So therefore this compound is again aromatic. Don't worry about this as of now. If you have this pyrrole ring fused with other 6-membered ring, then the name will change. So see, in this case I have this pyrrole unit, but it is again fused with one 6-membered benzene ring. So this together are called as indole or indole, right? So I have one pyrrole fused with benzene, it is called as indole. Have a look at the next one. So this is your 1,3 6-membered ring. So if you remember, 1,3 6-membered ring was pyrimidine. So if you have pyrimidine fused with pyrrole, then you will say it is purine. Fine. So pyrimidine and purine, pyrazine, these are all compounds are nitrogen compounds, and nitrogen compounds are also called as base. They are organic base. So these all are organic bases. All of them have nitrogen in them till here. So these are all organic bases. So I hope this is very, very clear to all of you. Have a look at the next one. Now I have substituted nitrogen with like oxygen or sulfur. So if you have a 5-membered ring and if you replace nitrogen with oxygen, so your pyrrole becomes furan. So 5-membered ring with oxygen is called as furan, right? Again, oxygen is the heteroatom, so the numbering will start from oxygen. Next case, if I replace this oxygen with sulfur, then the compound name is thiophene. So furan changes to thiophene. So you can see like one atom changes and the name changes completely. Next one. Now if I have a sulfur and if I have a nitrogen, then from where should I start the numbering? It will start from nitrogen. Nitrogen is given higher priority. So nitrogen is 1, 2, and then sulfur is going to be your 3, 4 and 5 and so on. Fine. So if I have nitrogen and sulfur together, then they are called as, for sulfur, thia, and for nitrogen, azole. So they are called as thiazole. So this were few very, very important aromatic compound. I hope this is very clear to all of you. We will just take a short revision just to see that if you remember the aromatic compound nomenclature. So I repeat, if you remember, I have started with, in the first lecture, I have given you some class name of aromatic compound. So that was the most important lecture. In the second class, I have started with halogen and nitro substituents. Then we have taken carboxylic acid and its derivatives naming. Today, we saw phenols, dihydroxyphenols, trihydroxyphenols, aldehydes, ketones, if you remember, amines, ammonium salt, and this hetero-aromatic compounds. So do go through all of them. If you have doubt, do ask in the comment box and we will catch you up soon in the next class. So see you soon in the next class.